Everybody get up.
Hey guys, and welcome to lesson 7.5, solving rational inequalities. So last lesson we dealt with solving rational equalities, and basically the difference between the two is in the process of which we solve these things. Let's take this inequality right here. 3x plus 1 over x minus 2 is less than 4. So let's handle this as if we were solving a rational equation and take the same steps as we did in the last lesson. So what we would have then is we would want to multiply both sides by the lowest common denominator, which is x minus 2. And when that happens, well, on the left side, the x minus 2's cross each other out, so we're just left with 3x plus 1 is less than, and then we'll distribute the 4 on the right side, giving us 4x minus 8. And now that we don't have any more fractions, we'd move everything to one side. Will give us negative x is less than. We'll take this 1 to the other side. Will give us negative 9. Now we need to solve for x, so make sure that we need to divide both sides by negative 1. And then what happens when you divide both sides of an inequality with a negative? The signs actually flip. Okay, so then for our solution to this inequality, we have x greater than 9. So what we'll do now is take a look at this graphically. So here's our function. If we were to graph it out, we would see that, well, when x is greater than 9, then most definitely our function is less than 4, right? Because our function was, when does the function 3x plus 1 over x minus 2, when is that less than the value of 4? So we can clearly see that there's our y value of 4, and yes, when x is greater than 9, not equal to, but when it's greater than 9, our function is most definitely below that. But take a look at the left side of this function. We have a whole chunk of this function that is definitely below the value of 4. So when we solved this inequality using the method that we did in yesterday's lesson, then we end up actually missing some solutions. Okay, so we actually miss the solution when x is less than 2. So what we need to do is we have to make sure that we have to take into account any vertical asymptotes that can affect our solution set. So when we are dealing with inequalities, you have to remember that there is a slightly different process. So instead of first multiplying to get rid of any denominators, what we're going to do is move everything to one side, just like we would if we were trying to solve for x and factor. We would move everything to one side, and then once there's 0 on one side of the inequality, then we'll find a common denominator. So I'll take this negative 4 here and multiply it by x minus 2. And if we were to distribute, this would become minus 4x and then plus 8. So don't forget, we actually have to distribute the negative 4. Okay, and then this is actually all over our common denominator of x minus 2. And then if we clean up and simplify the numerator, we actually end up with negative x plus 9 all over x minus 2. Now, this is the point where we create a sign line to find out where the function is above 0 and where it's below 0. So this is pretty much the same approach that we use when we are graphing. So we'll take a look at our numerator, because our numerator will tell us our x-intercepts. So when does negative x plus 9 equal 0? And that'll tell us our x-intercepts. Well, if x ended up being positive 9, then our numerator would equal 0, and we have an x-intercept. Now, when does our denominator equal 0? That's important because that's when we end up with vertical asymptotes. So when x equals 2, we end up with a vertical asymptote. So those are the things that go on our sign line. And so now we have 3 intervals to check as to when our graph is above or below 0. So we'll do some test values. Let's try when x is equal to 0, because that's less than 2. Subbing in 0 into here, we would actually end up with a positive over a negative, so altogether we'd end up with a negative value. In between 2 and 9, let's say try x equals 3. When we sub 3 into our function here, we'd have negative 3 plus 9, which is positive, and we'd have 3 take away 2, which is also positive, so altogether we end up with a positive value, and anything greater than 9, so let's try x equals 10. Up top we'd have negative 10 plus 9, which would be negative, all over 10 minus 2, which is positive, so altogether we'd end up with a negative value. Okay, so because our inequality states when is this function less than 0, so basically we're looking for when does our sign line say the interval is negative. So we can clearly see that when x is less than 2, we have a negative value, and we also see that when x is greater than 9, we also have a negative value. The solution to our inequality would be x such that x is less than 2, or when x is greater than 9. And that would be it. So we'll move on to some other examples. So I'll do the first 2 examples with you, and then I'll leave the third for you to try on your own. So in part A, remember that because we're dealing with inequalities, everything must be moved to one side. So 1 over x plus 1, and then minus 5. When is that less than 0? So at this point, I will get a common denominator, which is going to be x plus 1. So we have 1 minus 5 times that common denominator. Let's distribute. So 1 minus 5x minus 5. And then we'll clean this up. So we actually have negative 5x minus 4 all over x plus 1. So at this point, once you're simplified, then what we want to do is create our sign line. And on our sign line, we want to find out where the x-intercepts are. So I'll take that numerator, set it equal to 0. So we have negative 5x equals 4. So x must be negative 4/5. And then we also want to know where our vertical asymptotes are. So we take a look at the denominator, and we can clearly see that when x equals negative 1, we have a vertical asymptote. So on our sign line, we have negative 1, and we have negative 4/5. So let's do some test values. Let's try when x is equal to negative 2. Let's sub that into our equation here. So negative 5 times negative 2 actually gives us positive 10. Positive 10 minus 4 is a positive number. Negative 2 plus 1 is a negative number, so altogether that interval must be below. In between negative 1 and negative 4/5, so negative 4/5 is negative 0.8, so let's try x equals negative 0.9. So when we sub this in, we'll actually get a positive value over a positive value, so altogether that interval should be positive. And then finally, we'll try something that's greater than negative 4/5, so we'll try x equals 0. Subbing in 0, we should actually get negative in the numerator and a positive in the denominator, so altogether that interval should be negative. So then, taking a look at what the sign is in our equation, less than 0, so we're looking for negatives in our sign line. So that must mean the solution to our inequality would be x such that x is less than negative 1, or when x is greater than negative 4/5. So notice I didn't put less than or equal to or greater than or equal to, because the original question was asking us for less than 0, not less than or equal to. So we pretty much copy the sign. But when you copy the sign, you really have to pay attention to where the vertical asymptotes are. And so we'll take note of that in our next example. Okay, so in example B, we'll start off by keeping the x plus 2 over the x minus 4, and we'll move the x plus 4 over x minus 6 to the other side. And again, take note that this is less than or equal to 0. That'll be important a little later on. And we want to come up with a common denominator, which will actually be the x minus 4 and the x minus 6. So this x plus 2, this fraction here with the x plus 2, it is missing the x minus 6, and then minus the second fraction, which is actually missing the x minus 4. Okay, so at this point we will expand. So we actually have x squared, and then minus 6 plus 2, which will actually give us negative 4x, and then minus 12. And now because we are subtracting this expansion here, what I'm going to do is keep everything in brackets, so that way I remember to distribute the negative in a minute. So we actually have x squared, and then minus 4 plus 4, those terms will cancel out, and then we're left with minus 16. Now you'll notice that I will not expand the denominator, and the reason for that is because once we do our sign line, I'm going to have to factor the denominator anyways to see where the vertical asymptotes are. So I'm just going to leave it in factored form. Okay, so at this point we'll expand and distribute that negative. So we have x squared minus 4x minus 12, and then minus this x squared but plus 16. And then we will clean this up a little bit, so the x squareds actually cancel each other out. All we're left with is negative 4x, and then plus 4 up top, and then again our denominator stays as is. And it might be a little bit easier if we actually common factor the top. So we have negative 4 up there, and then we'd have x minus 1 up top. Make sure that you do factor if possible, because that'll let us know if there are any holes in our function, if anything does happen to cross out. Okay, so at this point we are fully simplified and fully factored, so this is the point where we will put in our sign line. Okay, so any x-intercepts, so taking a look in the numerator, I see that 1 would be our x-intercept, and our vertical asymptotes, we can clearly see when x equals 4 and when x equals 6. So there are actually going to be 4 intervals for us to check. And again, I mentioned earlier that having this less than or equal to 0 was really important. So what I'm going to do is actually label where my vertical asymptotes are, just so that it reminds me later on when I'm doing my domain as my answer, I'll know where to put the equal signs and where not to. Okay, so let's try out some test values. Let's try when x equals 0. So when that happens, we'd actually have negative 4 times negative 1. So 2 negatives. And then on the bottom, we'd have negative 4 times negative 6. So 2 more negatives. So 4 negatives altogether actually make a positive. Now let's try, let's say x equals 2. Up top, we have negative 4 times, well, 2 minus 1 would actually be a positive value. Subbing in 2 into the bottom, we'd still have 2 negative values. So 3 negatives altogether would keep that interval negative. Now let's try x equals 5. Well, we have negative 4 times some positive value. And then in the denominator, we'd actually have a positive value times a negative value. Only 2 negatives will make a positive interval. And then finally, let's try when x is equal to 7. Well, we'd have negative 4 times some positive value all over 2 more positive values, altogether making this whole thing a negative interval. So let's go ahead and write our final concluding statement. We want to know when this function is less than or equal to 0. Okay, so we are looking at when x is in between 1 and 4. So when x is less than or equal to 1, and x can actually equal 1 because that would give us the x-intercept. Our function still exists at that point. However, I'm just going to put less than 4 because our function will not exist at 4, so therefore I cannot write the equal to symbol there. And then the other interval is when x is greater than 6, and again notice because 6 was a vertical asymptote, I'm not going to put the equal to symbol there. So just something to really watch out for, especially when you are working with less than or equal to inequalities. Okay, so the last example I'll leave for you guys to work on your own. This will definitely be something that we'll take up in class. If you have any questions, make sure you're asking us in class. That's it for now. Take care, guys.